Hey everybody, thanks for coming. This is our talk on the lessons in our lakehouse and delta sharing. So if you are not bound for that talk, then please get off the plane now. My name is Geoff Freeman. I am a solutions architect for the T-Mobile finance department. My team has built a lakehouse, which we think is pretty cool. And I think after hearing this talk, you're gonna wanna have one too.
I built our access management platform at T-Mobile, and recently I am now a data strategy manager focused on unifying our architecture and our user experience.
So you're here because you're interested in building a lakehouse or a data mesh, and we've already built one. And we're going to tell you a little bit about our learnings, mostly about the lessons we've learned, and then our roadmap for the future and the lessons that we've learned, making progress there. So our legacy architecture, before we had our lakehouse, was we had an Azure data warehouse where we were integrating data from all across T-Mobile that hadn't been yet integrated into the enterprise data warehouse, but we were using it to drive operational reporting. We were trying to accelerate our tower build, and we went from building 10 towers a month to building 100 towers a week. And we could no longer manage it with the spreadsheet. So we pulled all of this data from across the enterprise and we put it in an Azure data warehouse. And that was working pretty well. But a lot of people wanted access to this data that had never been integrated like this before. And they started reporting on it, and it caused a few pain points. The first is that an Azure data warehouse does not scale for concurrent users. There's a hard limit on how many people you can have. And if you want to scale up and increase that limit, then you have to pay exponentially more money for your Azure data warehouse. So we had basically noisy neighbor problems. And then the other big problem that we had was that those noisy neighbors would block our actual operational ETLs. So now not only is data late for everybody who's doing the reporting, but data is late for actual operations. So the data strategy that we adopted, we focused on these 4 points. We wanted to reduce our data latency and ensure that we had fresh data. We wanted to make it easy for people to consume data without needing to move it. So make it easier for data to be combined with other sets of data. We wanted to eliminate our noisy neighbor problem, and we wanted to be able to scale linearly using commodity hardware instead of scaling up. So this is the architecture that we adopted. And we're not actually going to go into detail about how we adopted it. We'll talk about some lessons, but we have previous talks and we have documents on Medium that we've written about how we got there. But, and if you've been at a Databricks conference, you've probably heard about a lakehouse architecture already. But the big win there was separation of compute and storage, or as Bobby Thompson likes to say, church and state. And at its center, we use Azure Data Factory for our orchestration. We use Databricks for all of our ETL and for most of our reporting. And we allow people to use whatever compute they want to bring, although we've been moving everybody mostly to Databricks SQL. But they can use whatever it is they want to use. And the results were huge. Again, if you're at a Databricks conference, you've already heard how Lakehouse is great, but we had huge results. Our refresh cadence, these numbers are conservative and are also probably about a year old, but our refresh cadence went from a lot of data reports were every 6 hours, and now our average is 1.5 hours. Many of our data sets are refreshing on a 15-minute cadence. And the ETL processing time, again, this is conservative. Most of our data sets at this point are actually running about 5 minutes for ETL processing. Data mobility, again, conservative, but we haven't added any new people to our team. And we're up at least 30% in the number of systems that we've integrated into our lakehouse. And the time that it takes us to onboard a new data set is about a day. To onboard a whole new system is about a week, but that's mostly dealing with like network problems and stuff like that. Predictable performance. For your query availability to go up 1%, again, conservative, but to go from 1 9 to 2 9s, right now we're at 3 9s, and that's for actual system availability. And our query failures is way down from 60%. And it's also, you have to keep in mind that this is all query failures. It includes when I write a terrible query and it fails because of syntax errors. And economies of scale. We moved all of our workload off of Azure Data Factory onto Databricks. We've increased our workload. We have not increased the number of people that we use, but we've reduced our cloud spend by a minimum of 30%. And our resource efficiency, like right now, when we look at how often our compute is used, if it's running, we're at 96%. That obviously doesn't apply to like CPU and memory, but we're pretty resource efficient. So let's talk about some of the lessons that we learned on this journey. This is really why you're here. Most important one right off the bat is to have a roadmap for your transition. It's easy to look at like, hey, I need to move to a lakehouse architecture and say, this is going to be a giant, huge lift. It doesn't have to be. Break it into small, manageable steps. The first thing that we did was we made sure that all of our Azure Data Factory pipelines that we're loading into our Azure Data Warehouse staged the data as a Parquet file in ADLS before it loaded it somewhere, right? That's an easy thing to say. I'm going to change my pipelines to just store the data there. The next thing that we did was we started implementing data, like data schema by data schema, load it into tables in a Unity catalog. Again, that's something where you say like, these are my most important data sets. I'm going to move those. You can show incremental value as you're moving it. People will say, hey, this is worth spending time on. But as you're doing this, the thing that allowed us to scale out without needing to hire a whole bunch more people was we automated everything. Literally everything that you do. If you have to do it more than twice, just write a script. And it doesn't have to be perfect. You just write, this task, this one thing that I'm going to have to do every time that I onboard a new table, I'm going to write a script for it. And you can identify, here's the holes in my script, and I'll continuously improve it. But in order to enable that sort of continuous improvement, you have to treat your data engineering as software engineering. A lot of data engineering orgs that I've seen have a ton of one-off data pipelines. But the basic pattern is I'm going to extract some data. I'm going to transform that data. I'm going to go load that data. The place where things need to be one-off is usually I'm going to extract the data from this source. But once you've extracted it, like you have a weird REST API that doesn't have pagination, so you have to go write some custom extraction. You just drop it into a Parquet file, and from there, everything else downstream is the same, right? Don't try to build everything perfect the first time. And don't try to build 100% of what you're doing. Identify, this is my main use case, automate that, do continuous improvement, but keep it simple. Embrace commodity hardware. This is easy to think about. You don't want to have to scale up. A side effect of that is that if you do have to scale up, then often you should look at your process or whatever it is that needs this much bigger hardware and think about how to break it down into smaller chunks. But the flip side of that is don't optimize too early. Most of these workloads, if they're running, but you could tweak your CPU a little bit and save this, a fraction of your percent. It's not worth your time most of the time to optimize until you've identified this is the giant workload that is spending all my money. This is the one-off. That's where you want to spend your optimization. But for your mainline use cases, don't worry about it too much. Just make sure you have things automated so that when you do identify how to optimize it, you can do it one place. So those are our high-level lessons, but we want to dive down into one of them in particular that made a huge difference for us.
Yeah, so access and security. A lot of companies have a lot of data silos where getting access to that data is very hard. You have to send a lot of emails, maybe file tickets, reach out to folks that you've never heard of and you think they might have your data. Once you maybe find the security group that you need access to that has some strange taxonomy that differs team by team, you can maybe hope for access, maybe get that access. It's generally hard to do. Whether that data is in Snowflake, the same data could be available in Azure Data Lake, and they could have 2 different security groups. So it's very important to simplify your process, keeping things simple. We handle our security through Azure Active Directory security groups with 1 group leverage per security context. The security gets applied at the data lake layer, and then every virtualization on top of that. So if you're accessing it in dev, Snowflake versus prod, Databricks versus wherever, it's that same security group. Sometimes this requires an Azure Active Directory pass-through connection. Other things use SCIM, the system for cross-domain identity management, which allows you to choose one identity provider of your choice and have the permissions sync all the way through. This is something that we call conform security. So that's all well and good, but how do you get access to that data? We grant access to all of our security groups through something called Provisionator that we built. That is data access, compute access, storage, orchestration tools like ADF, code repositories, Power BI reports, you name it. So a little bit more about Provisionator. When you have conform security like we discussed, it enables you to provide a unified access management experience for your customers. And we built this with the mission of streamlining and democratizing access to T-Mobile data so everybody can make data-driven decisions. There are lots of third parties that offer solutions like this. Some of them are here, like Satori. So whether you make it or build it, these are the features that you definitely want to keep in mind. Automated approval gate generation, so who should approve that request for which person and why, as well as once all approvals are collected, automatically provisioning that access. Integrate it into your data catalogs in your applications. So when users are exploring and they figure out, oh, this is the data that I need, it's a one-click request. You want auditable access logs. I don't know if you guys have dug through Azure Active Directory security logs. They're very dense and very long. Not really good for building reporting off of. You also want, when folks leave your company, to immediately have their access to data be revoked. Azure has a staging period where they disable your account for 60 days. You still are members of those groups. A lot of the more recent security breaches in Azure have been due to reactivating those disabled accounts, as well as time-boxed access. So when you get access to a security group in Azure, you generally have that forever unless your company performs a very intensive and robust auditing procedure. We generally didn't, at least on our team. So automating that away was very nice. So every year, for example, you'll have to re-request access to that data. And like I said earlier, it's the one-stop shop for all data access at T-Mobile. It makes our users' lives very, very, very easy. So a little bit more about conform security. It's extremely important to create your security model early on and keep it simple. You definitely want it to be sensible. By that I mean, when you get access to that data in ADLS, it should be the same across all fabrics of compute like we were talking about. There's a lot of best practices. Those best practices will change over time. Adapt them to fit the needs of your business. Do not be dogmatic. You also want to have a single source of truth if possible. So we chose Azure Active Directory security groups for ours as our identity provider. Most of these compute fabrics, like we were talking about, offer SCIM, which enables you to manage the permissions in Azure and have them sync to something like Databricks automatically. So you're still only managing access in that one location. Just a tip there, if you are going to use SCIM, do not nest your security groups. For many reasons, SCIM doesn't like it, but it also makes inheritance very hard to audit. And the third is access management. You really want to get this one right. Your customers, this is how they engage with your security policies, through access management. If it's not seamless, it's not easy, your customers are going to be really frustrated, and it's not going to be done right. So in the effort of automating everything and keeping a conform security model, we have automated a lot of the orchestration of our lakehouse, like Jeff was talking about. What started off as a couple scripts has evolved into a PR-protected function app, where the managed identity itself of that function app, a robot has the permissions to do all the heavy lifting. So that's things like creating containers, creating compute policies in Databricks, spinning up data factories, rotating your secrets for your service principals, you name it. No longer do we or Jeff, our MTS here, have access to do those things themselves. It's all done through this function app. What's really nice is users can hit it through OAuth when they have a particular app role that was granted to them through a security group and Provisionator. That limits the amount of fat fingering they can do. They fill out a simple JSON of this is the container that I want, and I want it in this storage account with these security groups on it. And it spins it up automatically and registers them with Provisionator right away. Your users can request access to that.
And this is a great example of how doing things in a conformed, standardized way leads to continuous improvement that makes it possible to scale. So the original version of this that Luke wrote was a PowerShell script that it took me an afternoon to write. And it wasn't perfect. It didn't do everything that it does now, but it made scaffolding a new container, a new schema for our consumers, something that we no longer had to worry about, oh, the security group didn't get applied right, or the casing wasn't correct, or somebody fat-fingered one of the schema name, but they had it correct in the Azure Active Directory group name. Simple things like automating those sorts of ops procedures has a huge downstream effect.
Yeah, thank you.
So that's a little bit of some of the lessons we learned about our journey there. But we're really excited to talk about where we think our roadmap is going. And probably the aspect that we're most excited about is Delta sharing. So we really think that it's the future, and there's a lot of other companies that agree with us and have decided that they are going to fully onboard and move in this direction. You might have heard about a few of them this week. It seems like a vacation to me. Might have heard about a few of them this week. Salesforce announced that they are going to be all in on not needing to copy your data. We use them a lot at T-Mobile, and we're really excited about this. Another example is SAP. They have announced that they are going to share their data through Delta sharing. A little company you might have heard about that we are moving a lot of our workload to currently for our ERP systems is Oracle. Their autonomous databases natively support consuming and sharing data using Delta sharing. It doesn't have to be giant companies that use Delta sharing. O9 is a medium-sized company. We use them as a supply chain prediction tool. We are in the process of sharing data with them through Delta sharing and consuming data from them with Delta sharing. Another one that we use that is a little smaller than Salesforce, but still cool, is ScopeWorker. They are a procurement to service CRM and ERP SaaS. And we are in the process of implementing our Delta sharing with ScopeWorker currently. To tell you about the big lessons that we've learned so far, I want to go a little bit over the conceptual model of how Delta sharing works. The key aspect of Delta sharing is that a provider says, I've got a table. And that table gets registered in the recipient's catalog, wherever they're gonna register it. When the recipient says, hey, I want that table, it requests the table from the provider. There's some permission stuff that gets evaluated, but the provider is going to send a list of all of the files that are necessary to read that Delta table. And each of those files is shared with a shared access signature. It's a token. It's a short-lived signed URL that gives short-lived permissions to access that file directly. And then the client goes and reads that file directly. It's no longer going through the Delta sharing server.
Yeah, so some of the pros of Delta sharing, you can probably see how nice it is, but reduced latency is a big one. As the data becomes available in that vendor's data store, the one that they use, you have access to it immediately right away. They don't need to move it to some other location where then you hit an API to get it, or move it through FTP to wherever. It's right there, it's available immediately. Additionally, reduce data engineering to set up and maintain. You implement the Delta sharing protocol and you just receive that data. Super easy. You don't have to move that data around all the time. You don't need to copy it into your own system. There are some caveats there that we'll get into. But clearly it also simplifies a lot of the architecture. So this is how we've implemented it internally. When you have data in the same cloud, same region, all you have to do is add it to the same metastore. When it's a different cloud or different region, you need to set up delta sharing on it, and preferably using the same security group that you use in your own catalog. If it is totally different cloud, but the data is massive, and there's a lot of data there, perhaps it makes sense to create a replica in your own catalog.
Yeah, and we'll talk a little bit more about like when this is actually a good example. So Scope Worker, go ahead to the next slide. Yep. So Scope Worker is an example of where we are actually not just registering that data in our catalog and letting people go query it there. Instead, what we do is they send us a Delta share, and we set up a Delta live table that reads from that Delta share, and it's just it runs every 5 minutes. And the Delta live table handles internally for us the watermark of, is there any new data? Is there any new data? Is there any new data? And only our service principals have access to that Delta share. But the data that gets copied across, so we have a 5-minute delayed replica of the data that's available in Scope Worker is now available in Azure, and we're able to give our analysts access to that data there. So the key thing to understand about why you would do this is that if you're going to be querying this data with any sort of regularity, you want to copy it once if possible. You don't want to copy it a whole bunch of times. Talk about that in a second, but so some of the big gotchas that we've identified from Delta sharing. Delta sharing is an open protocol, and a bunch of these vendors are implementing it not using just the Databricks share. They're implementing it however they want to do it on the back end that meets that protocol requirements. So there are things that you need to make sure they have, or you need to understand about how they've implemented it that are going to drive your design decisions about how you're going to consume it. For example, do they support predicate pushdown? What predicate pushdown is when you run a query, it can be decomposed into different pieces of relational algebra, and the Delta Share protocol supports a limited subset of predicate pushdown, but not everybody has implemented that functionality. So that means that you might not get just the slice of data that you need. You might get the entire table when you query it. Another feature that's not necessary to be implemented in order to be Delta Share compliant is change data feed. That's what allows you to use Delta tables or Delta Live tables in a automated fashion. If they haven't implemented that for the Delta sharing protocol, that's going to drive how you're going to use it. And then even if they're using the Databricks version of Delta sharing, you still have to consider what you're actually doing when you run a query like select date key count star from the table. Like it has to read every file. It might not need to read, like copy the entire file across. It might just be able to read the headers, but it still has to access every file in order to determine, show me your statistics, right? Concerns like this become real when you're talking about Delta sharing, because if we're reading every file here, the stores are probably going to support it. Like Azure Data Lake Store, S3, these are designed for insane amounts of throughput. But we've seen where the actual authentication service that's providing those short-lived tokens throttles you. So you want to make sure that you're testing, you're identifying what your query patterns are going to be, and that you're taking that into your design decisions as you're implementing Delta sharing. And then coming back to what we were saying about whether or not you want to copy the data once or just give people access to it in the share, you need to consider egress fees. If people are going to be accessing this data frequently, running different types of query patterns that you can't be sure about, do you want to be paying the egress fees from your cloud every time somebody runs a select star from table? these do impact the storage is generally cheap, but compute is expensive. Storage is only cheap if you're not moving it across cloud all the time.
So some final thoughts. Data engineering is software engineering. You definitely want to create those abstractions and automations where you can. And the real key here is automating yourself out of a job. If you automate yourself out of your current job, I guarantee you there will be another job that someone will hire you for to automate yourself out of that one. It keeps going.
And so that's our talk. Thank you, everybody, for attending. I hope you got to where you were going.